All right, almost done with notes here for 2016. We have one more section to go after this, so we're almost there, guys. So this is 3.5, and we are going to be solving and, well, not really modeling, but solving logarithmic and exponential equations using the properties of logs. Some of these guys will be easier to do algebraically. Some of these will be easier to do graphically. So we'll kind of sort through this as we go along. So, I don't know why that's there. These G's are there for some reason. Okay, so the one-to-one properties basically mean this. So for any exponential function, f of x equals b to the x. If b to the u equals b to the v, then that means that the exponents u and v are equal. The key being is that b is the same base. Okay? If they're different bases, you can't set the exponents equal to each other. Bases have to be the same. Same thing for a log function. Okay? So for any logarithmic function, f of x equals log base b of x. If the log base b of u equals log base b of v, then again u is equal to v because, again, we have base b. The bases are the same. So that's really what we're looking for in these situations. Now, when we do an example, sorry, I have to fix that. We have this equation and the variables in the exponent, so we have to figure out a way to figure this out. Well, what happens first is this, okay? You must get the parentheses squared by itself. So the first thing I'm going to do here is I'm going to divide both sides by 20. Okay? So that takes care of those. I have 1/2 to the x over 3 power equals 5 over 20 reduces to 1/4. Now, those are not the same base. However, I can make them the same base because 1/4 is really 1/2 squared. That's a 2, not a z. Okay? So I can rewrite 1 to the 4th as 1/2 squared. Now the bases are equal. Well, by our one-to-one property, that means that I can take the exponents and set them equal to each other. Okay? So, times 3 to both sides to get rid of the 3 on the bottom, and x equals 6. Okay? So the key there, guys, is making sure that you get the parentheses to the exponent by itself. So if you got to divide or add or subtract, whatever you have to do, fine. And then if you have to rewrite one of the bases to make them match up, you go ahead and do that. Okay, now, I said before, some of these problems are going to be easier to solve algebraically, and some are going to be easier to solve graphically. This is one of those problems. And the reason why is that you have 2 e to the x's here. Okay? I mean, if you set this up, okay, and you wanted to solve this algebraically, okay, it's just, there's too much to do. You'd have to do, like, there's a special case you'd have to use, and quite frankly, it's too confusing. So what I would do is this, okay? I would graph e to the x minus e to the negative x over 2. And then on the same graph, I would graph y equals 5. Okay? So I would graph both functions, okay? And then I would find the point, well, really, the point of intersection. Find the point of intersection of the two graphs. Okay? So if you did it for this one, okay, you would get approximately, just so you guys know, that's approximately 2.31 is the x-coordinate of the answer. Okay? So I would say in a situation like that, I would graph it because trying to solve it algebraically is just going to be a nightmare. Okay. When you have a logarithmic equation and you're trying to solve it algebraically, okay? There's actually a couple different ways you can do it. In the name of consistency, I think I want to take this log equation and change it to exponential. Now, how do you do that? Well, there's no subscript here, right? It's just log and then x squared. Now, as you notice, there's nothing there. Since there's nothing there, we assume it is base 10. Okay? Now, that's the exponent. That right there, well, is the base. And again, if there's nothing there, it's a 10. And then the x squared goes on the other side. Okay? Now, we solve it like normal. 10 squared is 100. Equals x squared. I take the square root of both sides. So x doesn't equal just a plus or minus sign, guys. Equals plus or minus 10. Okay? Now, a couple things you could do here. Okay? It says up here that a particular algebraic method may introduce extraneous solutions. Okay? Or lose some valid solutions. Okay? Now, if you graph, okay, to verify, if you graph log x squared and you graph y equals 2 and find the point of intersection, hopefully there are two of them. Okay? And there are, by the way. Okay? So, do it algebraically, okay? But then graph it to see if both x values are in fact solutions. Okay? Now, the last one. We're going to use the exponential properties, or the logarithmic properties, excuse me, here. So we did condensing and expanding logs. We have an expansion here. We want to reduce this down to one log. So what I do is I take 3x minus 2 and I take x minus 1. Now this is a plus in the middle, so that means an addition means, what am I doing? Doing it right would help. Means I take 3x minus 2 times x minus 1. And that equals, now this 2 becomes an exponent. So it's ln x squared. Okay? So I took these two and condensed it to 1, and then I used the power rule over here to put the 2 up where the exponent is. Now, remember what we said all the way back at the beginning in the one-to-one properties. I have two ln's, which means the base is e, which means the base is the same on both sides. So what that means is 3x minus 2 times x minus 1 equals x squared. You can just drop the ln's. Well, when I FOIL this out, what do I get here? Okay, so 3x squared minus 5x plus 2 equals x squared. Move the x squared over. That's a minus sign, not an equal sign. Okay, couple ways you could go here, guys. You can factor it, or you can use the quadratic formula. It really doesn't matter. So we'll use quadratic formula just for the time being here. So A is 2, B is negative 5, C is positive 2. Let me make sure that's right. Yeah. So 5 plus or minus square root 25 minus 4, and you guys get the idea here. Sorry, x equals. So that's 5 plus or minus 25. Let's see, negative 4 times 2 is negative 8 times 2 is minus 16. Oh, this works out nice. 5 plus or minus radical 9 over 4. Okay, so that's 5 plus or minus 3 over 4. So let's see, 5 plus 3 is 8, divided by 4 is 2. 5 minus 3 is 2, divided by 4 is 1/2. Okay, now again, we want to see okay, if both solutions work. So here's what I do. I come back here, all right? And what I'm going to do, this is what I'm going to graph. Now you got to be careful here. What I'm going to do, okay, I want to find the 0. So what I do is if I want to find the 0, I take the 2 ln x and I move it over. So now this is ln 3x minus 2 plus ln x minus 1 minus 2 ln x, which equals 0. So to check for extraneous solutions, graph that in your calculator and find the 0. Okay. Now, what you're going to find is that the graph does not cross the x-axis at 1/2. It only crosses it at 2. Okay. So the deal is we're going to solve these algebraically for the most part, but then we can graph them to figure out if there are any extraneous solutions or not. Okay. So that's 3.5. We'll have plenty of practice with that, and I don't know if that was too entertaining. Probably not. Sorry I wasn't more bubbly with my personality, but you guys said, first period, you guys said you wanted me to do the video, so here I am. So I'm done, and we'll talk about this more tomorrow or something. Peace.